we think about our distance from 0, that x could be 7 or negative 7. But if I have absolute value of x and it is equal to any negative number, the key thing then is that we are going to have no solution because distance cannot be a negative number. So when we think about, we're going to be working with inequalities today rather than equalities. So when we thought of distance this way. So yesterday or last week when we did our compound, we were working with ands or ors. And so when we think about absolute value and we look at this phrase, absolute value of n minus 1 is less than 2. This is how we want to think of it, wording it. This inequality represents all the numbers that are less than 2 units away from 1 on the number line. So when you read that, you kind of got to think of, you're not reading it in order from left to right. The inequality represents all numbers, and you're going to start with this last part, that are less than 2 units away from 1 on a number line. You look at that next one, and again, you will look at how they read that. This inequality represents all numbers that are more than, why more than? Because it was a greater than 2 units away from 1 on the number line. So when you look at this phrase here, absolute value of n minus 8 is less or equal to 8, we're going to talk about the distance away. So we're always going to look at that. This is either our less than or less or equal, greater or equal, and this is the number that we are looking at. You don't count that negative sign. So what does this mean if we are looking at this phrase? So when we look at this phrase, we want to say it is, the inequality represents all what? Numbers that are less than or equal. Okay, so when we're thinking about that, we want to read this as, this inequality represents all numbers that are less than or equal to 8, that was this part, the distance away, from 9. Some of you are going, whoa, how did they come up with the 1 in 17? They did that by solving this, doing our 2 ways. So what we are going to be doing in your homework is I'll give you this problem. You are then going to split this. You have to do the positive, right, and the negative, just like we did before with our absolute value. So positive and negative split. Since our absolute value is alone, we would put n minus 9. And someone said, I know, but you said positive. The positive is because it is less or equal to 8. When we do the negative, you have to change 2 things. You have to reverse the inequality, and you have to put the opposite of 8. So now we're going to solve this with n minus 9. And this is where some of you will get mixed up. This becomes a greater or equal, and this is negative 8. So these two become the negative, or a lot of times we like to refer to it as the opposite. So in both cases, in order to solve for n, you are adding 9. You are adding 9 in both cases. But when you add 9, that's how we get this first part. N is greater or equal to 1. Because negative 8 plus 9 gives us this first half. Notice that they put the number first. Would you have to? No. You could write it this way. I would take the word and in between. And n is less or equal to 17. Why is it an and not an or? Because if I asked you to graph this, what are your possible numbers? It goes from 1 to 17. It goes in between 1 to 17. That is an and. I will tell you that on this test, I will take your answers written this way, same in your homework. But when you check it, it might be written this way in the back of the book. These are the same phrase. It's just written differently. Right here, we still read this as n is greater or equal to 1 and n is less or equal to 17. The same if I read it this way. Okay, so it's just a matter of, some of you will struggle rewriting it in the middle. But the key thing is, this is always going to be your smallest number, and then this is your largest number. And if it goes in between the two, you want to use the and or that phrase, versus when we are looking at ones that go away from each other. How do you know if you're going to go away from each other? So if we are looking at this next part, the solutions for absolute value of 8n is greater or equal to 24. First thing you want to think about, the inequality, you have to get that absolute value by itself. It is at least 24 units from 0, which means it could be less or equal to 24. This is the opposite. When you look at this opposite, I want you to notice that what did they take the opposite of? They took the opposite of the inequality and the opposite of the number. And then this is the one where they kept it right the same or the positive, where they just wrote 8n greater or equal to 24. Everything stayed the same. We're going to divide by 8 in both cases, division property of equality. We get n is less or equal to negative 3. The reason they used an or, greater or equal to 3. If it's in this solution or it's in this solution, it can't be like in both of them. It's going to either be in one or the other. So you're always trying to isolate your variable, keep dividing, getting it broken down until you have that by itself. So absolute value, split it into the two cases. If it's a less than, that's when you're going to use the phrase and. If it's a greater than, then it's going to be the or. So you're going to be really picky on checking this on the quiz. Yes, you got to have it the right way. You got to make sure you're getting that right phrase down. Okay. And then solve it as normal. So let's do that. Keep everything exactly the same. 2k minus 1 is greater or equal to 7. The other one with the opposite, 2k minus 1. This is where we are now switching this to less or equal, and it is negative 7. Okay? So when we think about the opposite part, the opposite is making these two things the opposite. When it's the same, you're just going to keep both of those two things the same. And now solve it like normal. Okay? So it's greater or equal to 4, or k is less or equal to negative 3. Because when I think of this solution on a number line, right, negative 3 is here, here is 0, here is 4. This is telling me that k can be greater or equal to 4, that's all these going larger, and less or equal to negative 3. The reason it's an or, they have nothing in common. So we'll look at this next one. Sometimes people like to do the opposite first. I don't care which one you do, you just got to make sure you keep one the same, one the opposite. 4r plus 1, if we're doing opposite, greater or equal to negative 1. If we do the same, 4r plus 1 is less or equal to 9. So please set up and solve those. This one, we're going to do it right away. 2/3 times p. If we keep it opposite first, greater than negative 8. 2/3 p less than 8. So work at solving. Awesome. What if you left your answer for number 2 to be r is greater or equal to negative 10/4 and r is less or equal to 2? Would I take that answer? Yes, it's the same answer. Oh, you didn't simplify. I probably am not going to take off points for simplifying because they were telling me that on the AP exams they don't mark that off also. Okay? If you simplified it to negative 5/2, perfect. Anytime you don't want to use the and, you could use it with just one variable in the middle. Yeah. I would say that if you're, yeah, you could have had negative 2.5. Yep, that would work. Okay. Here you should have multiplied on both sides, and number 3 by what? What am I multiplying by to solve the problem? 3/2. And if you do that, right, 8/1, and you're multiplying by 3/2, you should have had, been able to simplify, and that's how they got the negative 12 and 12, because here 2 goes into negative 8 4 times, so you get negative 12, right? Here 2 goes into 8 twice, 4 times, and 4 times 3 gives us a positive 12. Again, would it be wrong if you wrote it, p is greater than 12 and p is less than negative 12? That would be perfectly fine also, okay? But you will see a lot of times when it's the less than that they do it in between instead of using the word and. Okay. That last one, if you haven't done that one, my next step, if you were going to tell me the opposites, start me off. Is it Allison? Almadine, sorry. Go.
Opposite to AX minus 16 is less than negative.
Okay. And if we were looking at the other side of this, so this is our opposite, what am I going to be looking at? For the other opposite. 8x minus 16 is greater than 16, right? So when I look at that solution, is this going to be an and or an or? Which phrase should I be looking at? Or should be an or, right? And if you were solving it, you should have had s was greater than 4 or s is less than 0. What if you wrote it just the opposite? You said s is less than 0 or s is greater. Same thing, right? I just want you to make sure it's not different if you put one of them first, okay? But you can't write this as an and because there's nothing in between 0 and 4 that are equal. Okay? All right. This last part seems to, it's kind of like our one that we were looking at earlier with absolute values. Only thing now, we're going to be talking about variance. So, if we are reading this, anyone want to volunteer and read for me? Someone?
The company makes boxes of crackers that should be weighed 213 grams. The quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weight for a box of crackers?
All right. So, on your paper, you have a blank right here, right? You have absolute value of W minus what's our ideal weight. So, it is always going to be W minus the ideal, right? So, this is our ideal weight. This is what we're trying to achieve. We want that box of crackers that we're selling to be 213 grams. But it has to be within, so it's always going to be a less or equal, and then this is always your variance. So the ideal, and this is how it changes, or what we call the variation, okay? That is always our variation. So W minus 213, the absolute value of that, less or equal to 5. We have two possible answers. So when you take a look at yours, once we have this written, right, we now want to say, oh, well, what are my two answers? And you can actually, when it's less or equal, you can write it as W minus 213 is less or equal to 5. And then on this side, you're going to go greater or equal. This is your inequality, the changing to the opposite, right? So this would be the opposite, greater or equal, and we're going to put negative 5. Okay. Could we have split it into two different ones? This is the same, right, up to this point. If I underline this in black, this was the exact same as what our original equation was. If I look at this part that I'm going to underline in green, this is the opposite. Does that make sense? W minus 213 is greater or equal to the opposite. That's your negative 5. So as we are solving this, what do you really have to do with the 213? Add it to all three spots, just like your compound inequalities last week that we were working with. So what is the weight variance that we can use? The highest weight that we are accepting for these boxes of animal crackers is 218. The lowest weight that we will take, 208 grams, right? If we are looking at that. So the key thing to think about when you are doing these problems is that it is always x minus, this is your ideal that you're trying to get. And it's going to be less than or equal to the variation, okay? And if you can think of it in this way, It's kind of like when that skater was approaching you and going away from you, right? It was x minus how far away they started until less or equal to how close they were to you when that person went by you. So, in the next one, I want you to set it up. And then we're going to go through this one. The first one is going to stay the same. That is going to be W minus 32 is less or equal to 0.05. Here it is greater or equal. Will you see one like this on your test, either with the skater or one of these? Definitely will. Okay? In this case, this is now going to be greater than negative 0.05. How do you finish solving the problem? We are going to add 32 to all sides of that inequality. So, when we start with our first one, what should I be looking at for my weight as I'm looking at that, Brody? I should have
31.95.
31.95. Be less or equal to my ideal weight, which on the top side of that, then I should have, Emily?
32.05.
32.05. So when we are looking at that, that's how we're going to be looking at our weights. That's pretty much your answer. And we want to just make sure we put ounces with these for our weight. Okay? So as you are looking at your homework, we got another quality control, right? Quality control in both 47 and 48. And I think we're actually just doing the odds. So you got 33 to 47. Then we go to 62 and 68, which are obviously even ones, so you're not going to see those. I want you to take a look at 68 up here. So